We're going to subtract matrices and we're going to find additive inverses. This is 13.2b. We've got 3 previous videos for this chapter that are linked in the description if you need them. So to subtract matrices, we just subtract the corresponding elements, just like we did when we were adding. Just remember, they must have the same dimensions. So we have a matrix here and a matrix here, and we can subtract them. We do 1 minus 1 and 2 minus a negative 1, the negative 2 minus a 1, the 0 minus the 3, and the negative 3 minus the 2, and the negative 1 minus the 3. Very straightforward, pretty easy. We just subtract the corresponding elements. We have to make sure the dimensions are the same. This is a 2 by 3. There's 2 rows and 3 columns. And this is 2 rows and 3 columns. So they're both 2 by 3, so we can subtract them. We subtract the corresponding elements. This 1 minus that 2. See? This 3 minus that negative 1. This negative 2 minus that 5. This 4 minus that 6. This 0 minus that 4. And this 5 minus that negative 3. Just remember, when you subtract a negative, you add the opposite. So that's going to give us a negative 1 here, a positive 4 here, because we're adding the opposite. We're going to get a negative 7 here. We're going to get a negative 2 here, a negative 4, and we're going to add the opposite again and get an 8. All right? And we can get the additive inverse of a matrix by replacing each element with its additive inverse. For a matrix A, its additive inverse is a negative A. It's the inverse of A. When 2 matrices that are additive inverses of each other are added together, we make a 0 matrix. It's like a 0 pair matrix, isn't it? This and this is the additive inverse of this. See? There's a positive 1, we have a negative 1. We have a positive 2, we have a negative 2. See? Positive 3, negative 3. Negative 1, positive 1. They're just the opposite, aren't they? If we indicate matrices by A and B and an additive inverse by this negative B, this inverse of B, we can subtract by adding an inverse as we do with numbers. So I have a theorem for you. For any matrices A and B, A minus B is going to equal A plus a negative B. It's just like if we had 5 minus 3, that's a 2, right? It's the same thing as 5 plus a negative 3. That's still 2. Works with matrices. So we can subtract by adding an additive inverse. We have A minus B. Here's matrix A and matrix B, and we're going to subtract. And we get a 3 minus a 2. We get a negative 1 minus a 1. We get a negative 2 minus a 3 and a 4 minus a 2. A negative 2. And that's going to give us this matrix right here. And if we do it with an additive inverse, instead of a 2, we have a negative 2. Instead of a 1, we have a negative 1. Instead of a 3, we have a negative 3. Instead of a negative 2, we have a positive 2. If we add these, we're going to get the same answer. We're going to get the same matrix. So we could subtract, or we could do adding the additive inverse. See? So we can just subtract, or we can subtract by adding an additive inverse. We just have to make sure the matrices have the same dimensions. These are 2 by 2, so we can do it. See? These were 2 by 3, so we could do it. If you have a 2 by 3 and this one was a 2 by 2, we couldn't do it. It's got to have the same dimensions. Okay? It's really not that hard. You should be okay. So our next video is 13.3a. We're going to talk about determinants of 2 by 2 matrices, and I'm going to have a link to those 3 previous videos for chapter 13. If you feel like you've missed something, you can just watch them real quick. They're not very long. And I'll add this to the Algebra 2 playlist, and we'll move on to the next video. All right? I hope I'll see you there. Bye.